2 squared. Number 2, 17x to the 8th, y to the 12th over x to the 9th, y to the 7th. 4x squared y squared times x to the 5th, y to the 3rd squared. Let's try those three. Let's try those three. Oh, statistics. All right. So we're going to start you guys off with this. We're going to say, that 63% of people will buy Valentine's gifts. All right. So 63% of people buy Valentine's gift. If we select, we're going to select 5 people. We're going to select 5 people. What's the probability that all 5 do not buy a gift? What's the probability that at least one does buy a gift? And we're going to star C because you haven't seen this yet. But what's the probability that exactly 3 buy a gift? We're going to do this next week. We're going to do this next week. But I'm going to show it to you right now. All right? Right, if I can sneak behind you. We're going to call this the special request area. What class you in, Dave?
Pre-calc.
How did you get suckered here? Well, I have to tell you, okay, that this is going to hurt you a whole lot more than it hurts me, right? Like, I'm not going to lie and be like, I was going to hurt you worse. No, it's not. It's going to hurt you way worse. Here's what I want you to do. By special request. Because what are you doing right now? You're just on like Instagram or something?
No. I'm doing hard.
What is that?
Pre-calc.
What are you working on? Matrices?
Okay.
Okay, great. So you do matrices now?
Yes, like the introduction to it.
The introduction to it?
Yes.
Okay, great. So I'll give you an introduction.
Okay.
All right.
Last time
So,
whatever we said.
have you
If there was
done
a remainder, I divided it by.
reduced or echelon
There's a
format?
remainder of 1.
Yes.
So you solve
remainder
system
of 2,
equations using
Negative 1.
Yes.
Negative 3. Negative remainder is 0. 1. So remainder of 3. what's the
Right now I'm
remainder?
working on,
Since there's remainder of
what says the dimensional matrix
remainder of
and, to describe it. But that's, I think, like the simplest problem here.
Okay, well, you keep working. I won't give you any problems.
remainder is
You keep
So you
working.
do
Hey, Lincoln,
2.
I'm gonna give you special requests right here. I want you to solve, 3x plus 5y equals 23,
I was thinking it was.
and 8x minus 7y equals negative 20.
Okay.
So you're doing both.
Guess you could reduce it all to half. Yeah, that's what, Do we need to reduce it?
Hey, college algebra, are we ready yet?
Do we need to reduce it?
always.
You're about like 30 seconds.
Yeah, the dude wanted me to buy the Hero 8, Brandon. And I'm like, my wife don't know I spent $180 on the Hero 7 that I just bought. Nor did she know that I bought all this extra peripheral shit you told me to buy. So does that mean I can take that other thing back?
Which
The little GoPro holder?
not yet.
Okay,
I'll talk about it.
all right, that's fine. I mean, if you tell me I need to buy the $400 one, then I won't be happy about it, but we're having a meeting here soon at the college to discuss college-wide finances and what the math department needs. I'm gonna make a very compelling case that we need a GoPro 8 Black. I mean, and we need funding for Chick-fil-A.
And donuts.
I mean, that is the more important one. We need funding for this. I think if we can tie our departments together on that, you get it.
Yeah, like, I think it's kind of ridiculous that I have to buy the shit. But then again, I don't think they care. And let's be honest, I'm just trying to avoid any face-to-face contact. That could lead to getting fired, so. It's kind of like, hey, are you available? We need to meet. No, I'm not available.
Would email work?
That's right, I'll never find you over email. All right. All right, so I gave you an extra 30 seconds. Did that make it better? All right. 255 divided by 4. That's the key here. The key to this is you take that number, you divide it by 4, and then you look at the remainder. If the remainder is 0, you say the answer is 1. If the remainder is 1, you say the answer is I. If the remainder is 2, you say the answer is -1. If the remainder is 3, you say the answer is -I. That's what you do. You divide by 4, and then you look at the remainder. Okay? I had a student one time ask me, well, what if the remainder is 7? Divide again. All right, just keep dividing until you don't get anything other than one of these 4 numbers. All right? Now, 255 divided by 4, then we're going to old school here. Right? Some of you kind of forgotten how to do that. 4 goes into 15 3 times, that's 12. This is a remainder of 3. So we look at the remainder, and that tells me that this answer is -I. What's up, Lincoln? Oh, okay. All right, so that's how you do I raised to a power. Okay? Spoiler alert, it's on the 3rd test. Okay, guaranteed. Right? This one, you got to distribute the minus sign. 8 minus 6 is 2. -4i minus 7i is -11i. 2 minus 11i. I feel like Forrest Gump. I don't have anything else to say about that. All right. This one beat your butt. Hey, Brad, you ain't ready for this yet. No, this is baby Brad.
Yep.
Baby Brad ain't ready for this. This is big boy Brad. Why is this one so hard? Because what a lot of people want to do is do 24 plus 9i squared. Man, they feel so good about that. They distribute the 2, and they're like, oh shit, I mean shoot. Brantley, we need that dump button. 8 squared plus 9i squared, right? That's not, Camille, you don't do it that way, baby. What do you gotta do, Camille? You gotta FOIL it. Every time you get a binomial, you gotta FOIL it. So we got 8 plus 3i. 8 plus 3i. We got 64. We're gonna get 2 of these 24i's, right? We're gonna get one going this way, but then we're gonna get one coming back the other way. And then we're gonna get 9i squared. Okay? Which gives us a final answer of 9i squared is -9, right? So we got 64 minus 9 plus 48i. 64 minus 9 is 55 plus 48i. And that's our answer for that. We good? All right. Now, for this one, got to multiply by the conjugate. Got to multiply by the conjugate. So we're multiplying by 4 minus 2i. It's the same piece, swap the sign in the middle. Somebody asked me yesterday, can we swap the sign in the front? Is it the same thing? No, you got to swap the sign in the middle. The reason is well, could you swap the one in the front? Don't do it. Swap the one in the middle, although you might be able to. All right. Bottom piece, 16 minus 4i squared, yes? Brantley, can we see that okay?
Yes.
16 minus 4i squared. I squared becomes -1, so this is 16 plus 4. That's 16 plus 4, which is 20. Now, what is the top piece? The top piece, we got 5 minus 7i times 4 minus 2i. This is 20 minus 10i minus 28i plus 14i squared. Again, the I squared is -1, so this becomes minus 14. So we got 6 minus 38i. Now, once you get to here, you're almost done, but we do want to write that in standard form. How does standard form look? 6 over 20 minus 38 over 20 I. We simply separate those into two pieces, making them, making this 3/10 minus 19 over 10 I. You could functionally accomplish the same thing by factoring out a 2, making this 2 times 3 minus 19i, and then taking the 2 and the 20 and canceling. That functionally accomplishes the same thing. All right. Questions, comments, concerns?
Does I squared always end as 1?
Always takes out a -1, yes.
Negative.
I squared will always become -1. If the day ends in y, it's -1. All right. Questions, comments, concerns? Now, let's do this. Let's do this. I'm going to erase this. We're going to go f of x equals -3x minus 5 squared plus 4. You know what? Because you came in on a Friday, let's go plus 12. Let's go plus 12. Oh yeah. Oh yeah. Let's go domain, range, increasing, decreasing. You okay? I'm doing this for you. Let's go is a vertex. Let's find the vertex. Let's determine whether that vertex is a maximum point or a minimum point. Let's determine whether the graph is concave up or down. You know what? Let's go ahead and do all of it. Let's go equation of the axis of symmetry. You know what? Why are we stopping? Let's go y-intercept right here. And we go special gift, not even wrapped, kind of in the gift bag, because you know it's a special gift if it's in the gift bag. What's the x-intercept? I got a special prize pack to anybody who can come up with the x-intercept. If you're watching at home, you should have been here. All right. You know, it just occurred to me, Brantley, if I go like that, I can actually see what the hell's going on.
I think you can flip it all the way around.
You know what, Brantley, let's don't get crazy. You're trying to break my stuff. All right, here. What did we get? Start us off.
64.
64, excellent.
Y to the 4.
64, what, baby?
X to the 8th. Y.
64, x to the 8th, y to the 4th. Awesome. Awesome. Ty, what'd you get for the next one?
17y4 over x1.
17, y what?
4?
4?
5.
5? All right. 17, y to the 5th over x. Do we agree?
Yeah.
When you subtract the exponent stays on wherever the bigger exponent is. If the bigger exponent's on the bottom, you subtract it and the answer stays in the bottom. You have the bigger exponents on top, you subtract them and the answer stays on top. We good?
Mm-hmm.
Here, who else is in intermediate? Camille. No, you're college algebra. Somebody else is in intermediate.
It's only me, I don't have that question.
Well, what were you waiting on, Lincoln? Oh, you were doing that over there. I understand, priorities.
Well, I did the first two, but then like you threw that, and I was like,
That was special request, Lincoln.
yeah, I didn't request it.
You didn't request it.
It was special. It just made me feel special.
All right. What'd you get?
16, x to the 14th, y to the 8th.
Nice.
Oh, that's
Nice.
special.
Did you get that? So this is 16, x to the 4th, y to the 2nd. You're kind of distributing, but not so much. X to the 10th, y to the 6th. And now you're adding the exponents. 10 and 4 is 14. 2 and 6 is 8. So 16, x to the 14th, y to the 8th.
Yeah, I botched it. I did not double get to the 16. Everything else was fine.
Everything else was good. All right. Now, we good? Now let's just see how good we can do. Let's play in the negative exponent playground for a little while. See right there, that was kind of the kiddie pool. And the water's always warm in the kiddie pool, but I'll never tell you why. All right. 8x to the negative 2, y to the 5th squared. 5, x to the negative 4, y to the negative 3. -7, -7, x to the negative 6, y to the negative 3rd cubed. Let's play with that for a while. All right. What's the probability that all 5 get the day off or buy a gift? Brantley, did you buy a gift for your mom today?
No.
See me afterwards. I might have a mini HDMI something you can give her or something.
Okay.
Maybe a Electrical cord. All right. What's the probability that all 5 do not buy a gift? Well, 63% of the people buy a gift. So what percentage doesn't buy the gift? 37. DJ, did you get 37? You're lying. You sure? All right. So probability that all 5 do not buy a gift, 0.37 raised to the 5th. 0.37 raised to the 5th. Jasmine, we good, baby?
Yeah.
What class are you in?
College algebra.
Okay. All right. You done already?
Yeah. I don't know all of them, but I know most of them.
All right. Now, what's the probability that at least one person does buy a gift? That's 1 minus the probability that they all do not buy a gift, yes? So that becomes the 1 minus 0.37 raised to the 5th. Okay? Now, what's the probability that exactly 3 buy a gift? This is what you haven't seen yet. Terry, and you haven't seen this yet. The probability that exactly 3 buy a gift is 5 choose 3. You don't know it, I'm just telling you. It's 5 choose 3 because we don't know which 3 of the 5 will buy it, but we know that 3 do buy it and 2 do not. Does that make sense? 3 buy, 2 don't. So this is, I don't know which 3 is going to do it. And then I need 3 people to buy a gift. Well, how do you do that? That's 0.63 raised to the 3rd. That's 0.63 raised to the 3rd. That's 3 people buy a gift. Now we need 2 people not to buy a gift. And then you would type that in. I don't know which 3 are going to buy it. This is the probability that 3 people buy a gift and 2 people do not. Okay. What is that?
I don't know. I don't know what's inside.
Well, where did you get it from? Oh, it's a freshness packet. I would encourage you not to eat it.
Like what is like inside of it?
Baking soda.
It's not baking soda.
Well, then how the hell did you ask? Why did you ask me?
Because baking soda is soft. It's like a powder. It's like a powder.
It's compressed.
Compressed baking soda.
Yeah, absolutely.
Then why is
100%.
that you can't eat it? Because you can eat
What's
it.
wrong with baking soda?
No one eats baking soda plain.
People
Just
brush their
saying.
teeth with it, don't they?
No.
Yeah, that's the hard way to do.
That's fluoride. All right. Any questions on these? DJ, we good, man? All right. Let's try a very similar one just to give you another chance. All right. I was talking to a dealer guy yesterday. He lives in Nebraska, DJ.
Yeah, I know. Yeah.
He said it was like 18 degrees. I'm like, 18 degrees? He's like, what's the weather like where you're at? I'm like, dude, I don't even want to tell you. And he's like, no, what is it? I'm like, dude, you ain't ready for that. Like, what we're having right now is your summer. Like, I love this. Don't you like the weather, Brad? It's nice, isn't it? It doesn't rain. We're going to say that in February, there's a 10% chance of rain on any given day.
Yeah.
Okay? We're going to say there's a 10% chance it's going to rain on any given day in February. All right? Now, how many days are in February? 28. We're going to say 28. I know this is 29, but we're saying 28. So, in 28 days, let's find the probability that it rains every day. Rains at least once. Let's find probability that it rains exactly 4 times. All right. Hey Ryan, did you help him with the special request?
No.
You did not.
I didn't ask for one, special request.
Hey, how'd you like that, Brantley? Bet your GoPro won't do that. All right, special request, here we go. Hey, Lincoln, when you see this, if the X's and Y's are on the same side like they are here, elimination is probably the easiest way to do it.
Oh, that was 2 different.
Yeah, you gotta get a whole X, Y, over here. Multiply this by 7, this by 5. In doing so, the 7 and the 5 become 35. The 5 and the negative 7 become 35. They'll cancel. It'll leave you a one-step equation. 21x plus 35y equals, I don't know what that is. I'm gonna say it's 161, approximately. I'm trying to be humble. 40x. Thanks, Brendan. 40x minus 35y equals negative 100. Do we agree? 61x equals, those cancel by design, 61, and x is equal to 1. You add these down, those cancel, 161 minus 100 is 61. X is 1. Once you get x is 1, 3 times 1 plus 5y equals 23. 5y equals 20, as you'll subtract 3 to both sides. Y is equal to 4. If x is 1, y is 4, that's your ordered pair.
Yeah, then, yeah.
Let me get a calculator out.
I see now.
You got a fancy
Right,
coffee
well,
jug.
I remember that, those are the steps.
You do or you don't?
The last step you did, after x,
After x equals 1, all you do is go back to the original equation and plug it in.
that drew it away.
Thank God you're here today. All right, we good?
Can I write it down?
Well, of course. Here, you write that down. I'll give you second special request squared.
I think you should do that, just send it one time to answer that one.
Not doing that.
He doesn't trust us.
It will never have to be the same.
Yeah.
Because I wanted to see how you did it. I'm gonna try to do it by this.
Is this the function? What's the domain? What's the range? Special request. Hey Brantley, can we see the special request?
Yes.
That's the special request right there. All right, that was for Camille. All right, college algebra, let's do this. All right. What does this graph look like? It is a parabola that is concave up or down? Down. How do we know that?
Negative.
Negative sign out front tells me that it's upside down. So it looks like this. What is the domain of that function?
Negative infinity to infinity.
I know I shouldn't do this. I know I may go to hell. If you miss the domain of a parabola, I want to give you the mark of shame. The domain for the parabola will be negative infinity to infinity every single time. Every time. There will not be a parabola where the domain is not negative infinity to infinity. So Brad, if you don't put negative infinity to infinity, you're getting a green dot on the forehead, and you're just going to walk around all day like this. Dude, why do you got that dot on your head?
Mark of shame.
It's the mark of shame. All right? Oh, it's always negative infinity to infinity. Now, if you mess up the range, that's totally understandable. You don't get the mark of shame for that. You only get the mark of shame if you don't put negative infinity to infinity for the domain. All right? What's the range?
Negative infinity to 12.
Negative infinity to 12. Very good. Negative infinity to 12. We're going to put the bracket in parentheses on 12.
Bracket.
Bracket. Definitely a bracket.
Yeah, definitely a bracket.
Definitely a bracket.
Hold up. Yeah.
I mean, like, what would you be thinking if it wasn't a bracket?
Yeah, like, that's what I had.
Yeah, absolutely. When's it increasing? Now remember, what is this point on the top? What is that point? That's called the vertex. What is it in this case?
512.
It is 512. It is a maximum point. We're going to get to that in a second. But in order to do increasing, decreasing, we need to know what that point is. Okay? When's it increasing?
Negative infinity to 5.
Negative infinity to 5. When's it decreasing?
5.
We just established that the vertex is 512. All right. What's the max or min?
It's max.
Is it a max or minimum? It's a maximum point?
Yeah.
Is it concave up or concave down?
Down.
Concave down. This one is uber hard.
Is it?
This one is uber hard. I'm telling you. And you can say like, no, it's not. But here's the problem. You're seeing it for the first time. I've been grading these tests for 15 years. I'm telling you, that one's uber hard. What is it?
X equals 5.
It is x equals 5. It's the x equals, that's the hard part. I'm telling you, you would not believe how many people I see go like this. Ah. That's not an equation. And then I had somebody go, my bad, equals 5. X equals 5.
That's equation of what?
The axis of symmetry.
Oh.
Appreciate that. What we're asking is, what line cuts the graph in half so that if you flip it across, you get an identical replica on the other side? Okay? For the standard parabola, the axis of symmetry is the y-axis. It cuts it in half. But when we start to shift it, we start to move it. Okay? And by the way, y-axis is not an acceptable equation of the axis of symmetry either. It's x equals 0. That's the equation. Okay? What's the y-intercept?
Negative 63.
Negative 63. All right. 0, negative 63. All right, prize pack. Who's got it? You do? What do you get?
7-0.
Who?
7-0.
That's your answer?
Yep.
That's it. You're just saying the answer is 7-0. Who else got an answer?
Is it a parenthesis, a 7, a comma, and a 0, and a parenthesis? Would that be better?
Are you looking for two answers here?
Oh,
There's two answers.
yeah.
Why are there two answers?
Because it intersects X in two places.
It intersects the x in two places. Now let's take a look at how you would find this.
I did that wrong.
You would set it equal to 0, right? You would move the 12 over.
No, wait. Yeah, I should have said.
What? Because you're trying to leave the x alone to you.
You gotta get x by itself.
Oh, okay.
So you divide by -3. You get x minus 5 squared equals 4. You get x minus 5 equals, and this is where you gotta be careful. It's plus or minus 2. See, as a general reminder, x squared equals 9 does not mean that x is 3. It means that x is either 3 or -3, Brad. All right? You had class time?
Yeah.
Take care, man. Appreciate you coming. Did you get the answers
For the last one,
for these three?
I'll just get them on Tuesday or something.
Okay. That's a good idea. Why don't you just watch it on YouTube? Didn't even think of that. So you get x minus 5 equals 2. That does give you the 7 that you speak of. But then you get x minus 5 equals -2. And that gives you x equals 3. And that's different. That's different. All right. What's that?
Said he had one of them, so that's good.
Oh yeah, absolutely. I mean, I get you half the price back.
What's the prize back?
Well, too late now.
You got any more of that moon thing?
I do.
Really?
I actually have 3 more of them.
I've never played with it.
But you're not going to get it because you didn't get it right.
Well, I can always get another one.
You can't get like half of one.
Half of a moon's hand.
We can split it.
But you didn't get anything right.
You didn't. Oh. You don't need to do it.
All right, we good?
Wait,
Yeah.
no, let me take a picture.
That's some good too.
So how would you write the answer for like x intercept? You would have put it in
You
parentheses?
would put it as 7, 0, and 3, 0.
Oh, okay.
That order pairs. You out?
Yeah, I got it.
Hey.
Oh, you got to practice at 10.
But I got my rehab for my knee.
Oh, okay. All right, he helped you get those straight?
Yeah. I got that.
All right,
Like, you let him know that, Kim.
I'll tell him. Yeah. Make sure you watch the rest of it, because there's some other stuff you need to see. Make sure you watch it on YouTube. All right. Any questions? Yeah, totally. 100%.
You do it.
I can't get lucky like that.
Why not?
You're like Buzz Lightyear flying. You didn't really fly. All right. Any questions? Now let's ask this. This one's going to be so great. This is f of x. When is f of x equal to 0? When is f of x less than 0? And when is f of x greater than or equal to 0? Question 2. Write the equation. Oh, this is going to be wonderful. Write the equation y equals ax squared plus bx plus c. where the vertex is 2, -1, and passing through, you're welcome. Five, 7. You're welcome, Brad.
Yep, thank you.
That's fantastic stuff right there. All right. We're ready. I want to thank you for coming, and I say that I'm being serious, right? Like, 'cause sometimes I am being that, but I'm not being that this time. Because the other girl who was like, oh, bring me 4 Fruit Loop donuts, didn't even show up.
Right.
So 4?
And then said she would pay for them.
Max.
Did you get 2, babe? Or you can have 6 now, because the other girl asked for 4, her ass didn't come.
I was wondering why you had 2 boxes. Most times.
I mean, look, I just try to accommodate requests, you know what I'm saying? But there will not be 2 boxes next time, I can promise you that. See, my mom will raise ugly people, not stupid people. All right. Here we go. What do we get? What'd you get, baby?
64 y times over x4.
Nice. Nice. What'd you get for the second one?
X12 over 125 y to the third.
Are you getting these by yourself, or did Ryan help you with them?
Yeah, well, I just like confirmed because I
He
knew with
confirmed
the
that you were
negative
right.
exponent, I knew I had
I
to like
confirmed
divide.
one, all the rest were.
Yeah,
Good job. These are not easy.
they're pretty easy.
Sounds like she wants a harder one.
No doubt, right? Wait till she sees the next problem.
Negative 343 over x to the 18th y to the 9th.
Negative 343 over x to the 18th, y to the 9th. Nice. Lincoln, we good?
Yeah, I just didn't put it in practice. I
What?
have everything like.
Lincoln. You cannot say you're good, I just didn't write it as a fraction, because that's the actual answer.
I know, I just put it in like one long line. That was just, yeah.
Oh, so then you're wrong.
Exactly.
Okay, all right.
You can address that. It's all you.
But I'm gonna try that. I bought you a gift, I just left it at Walmart.
Oh. That's happened to me too many times, honestly.
All right, we good here? All right, let's go next level. Let's go next level. 8 x to the negative 2, y to the third, z to the negative 5 squared times x to the fourth over x to the negative 2, y to the third to the fifth.
Is that a z on the bottom?
Yes,
Okay.
a z. You know what? I'm going to put a z on the bottom there too,
Oh, no.
because I can.
I didn't tell you before.
Now, so we're going to go there. This is as hard as it will get for you. I mean, it doesn't get much harder than that. All right, so if you can navigate that, you did good. Let's start your thought process into factoring. Okay, that's where we're heading next week. So let's go ahead and start that thought process right now. Let us factor 18x plus 24y, and then let us also factor 6x squared y to the fourth plus 8x y to the seventh. So we're going to call these, milk, chocolate, candy. It's Valentine's Day. Yeah, not dark chocolate. Dark chocolate's gross.
Yeah, it is gross.
Brian, I will
Hey,
kick you
I
out.
will just take it as I will never be out of dark chocolate because of you.
You will never. Dark chocolate is only good at night if you're in a bind and you just need something to munch on. 100%. I mean, because there's sometimes where you wake up at like 11:30 at night and you're like, why I'm so hungry, and then you're like, whoa, where's some chocolate? And then, like, I don't know what happens. I mean, it's just. And then you go out and you're like, where's the milk chocolate? And then you're looking for your Doves, and then you're like, whoa, I don't have any
Then you know
Doves.
they're not gonna be there because you ate them.
And then you're like, wow, I got this dark chocolate. And you're desperate at that moment. I mean, at that moment in time, you're desperate, so you eat it.
Straight.
See, when you love dark chocolate and you don't like milk chocolate, you go for that, and then you can turn away all the other chocolate. It doesn't help, you still wind up fat in the end.
Yeah, if I'm gonna get fat, I just wanna do it enjoying milk chocolate. I mean, I'm just saying. I mean, like,
You do you, man.
when you go to Cheesecake Factory, you don't see like dark chocolate cheesecake.
You do the one in Sarasota. Yeah, it's great.
Hey, who's the statistics? Terry Ann? Anybody else? What's the probability it rains every day? 0.10 to the 28th. Now, a problem like this, Terry Ann, will be set up only, because if it's not, you're gonna get a really, 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 really ugly decimal. All right? Probably 1 times 10 to the 28th and 29th or something like that. Negative. All right? So generally, this is just set up only. Just write it down and set it up. Okay? What's the probability it rains at least once? That's 1 minus the probability that it doesn't rain at all, which is 1 minus 0.9 raised to the 28th. Did you get that, baby?
Yeah.
For real? For real? All right. How about exactly 4 times?
28, choose 4 times.
28, choose 4 times.
0.9 to the 28.
0.9. So if it rains 4 days, how many days does it not rain?
So to the 24th.
0.9 to the 24th. 0.1 to the 4th. Thank God you got here. I was just talking about you.
Really?
Yeah. About the people who said they were gonna come and then didn't come. I was gonna tell you to put it on your resume as a line.
Oh, wow.
I mean,
Very detailed, too.
I'm definitely on time sometimes. You good? You good? You sure? All right, Terry, let's ask this. So yesterday I went to go buy a TV component. And in order to pay for it, they asked me to use PayPal, which I have a PayPal account, but I don't know how to use it. Or I could use Amazon. So this outside vendor let me use Amazon to pay for my little T-Com board I bought for this TV that I got. It's
Well, that's
broken.
interesting.
And then Amazon made me authenticate my account, which I thought my face did, you know what I mean? Because it has a little Face ID thing. I just look at it, it's like, ooh, it's you. And then it sent me a 6-digit code that I had to check my email so I could go back to the website and type in my 6-digit code. And it got me to thinking, how many 6-digit codes are possible? So you probably would have just typed in the code and left it alone. Haha, not me. I was like, that's weird. They were all letters though. And I can confirm, because of the code I got, that you can totally repeat the letters. Okay? So how many different codes are possible if we're using all the letters in the alphabet, and A, you can repeat letters, B, you cannot repeat letters.
Well, that's with repeating.
Now, let us also do, we're gonna play paper, rock, scissors. Yeah, we're gonna play paper, rock, scissors.
You say it like that.
What's the probability we lose 4 times in a row? Terry Ann, what's the probability we lose 4 times in a row? You know how paper, rock, scissors work, right? You go like this. Do you understand the game, baby?
Yeah.
Okay. Because you look like you don't understand the game.
I thought you were asking me to say the answer now.
No, don't say it now. Give Dino a chance, because he's over there on Snapchat. Hey, Lincoln, special request. Lincoln, I just want to say that if you missed this one, I don't know who this person is here, and I know you probably don't care about her, but if you miss it, she is sentenced to another donut.
Another domain.
She has to have another donut. Unconfirmed that it might be the Fruit Loop plan.
All right, don't worry about it. I got you.
So it's
Wait, who asked me for the plain donut? Is that you? Do you notice that you're an hour and 15 minutes late and nobody took the plain donut?
Wow, what's the probability? Yeah.
The probability that nobody takes the plain donut is 1.
Yeah, that one.
Because nobody is going to take the plain donut. No one looks at that plain donut and goes, oh, I want that one.
It's like you looking at dark chocolate.
Yo, I don't know, but we
No,
saw like
I-
Publix and like half the people actually take the plain donuts.
That's
Over,
good.
like everything else. Yeah.
Well, that's because your other options are crap. Your other options are powdered sugar or cinnamon.
No, we have glazed, we have the,
Well, the glazes are usually 4 days old. All right.
let me refresh everyone.
All right. Is this a function?
Yes.
What's the domain?
Negative.
Okay, so what? First, I
What is it?
Negative infinity to positive.
Good.
And what I did is I figured out there's an over like 3 and eight.
Bracket, negative
So I
4
just
to
went
positive
to the left
infinity.
because it looks like a parabola. And if that's the
What is it?
vertex,
Negative
it
2.
passes through that point. It gives the heat.
Wait, okay.
It's the y value.
I saw it differently.
It's the y value.
It could be, yeah, because it can't be a
I
line.
call it donut.
Huh?
I call it donut.
And so then it's how much. Because that just like put it on.
Apple fritter is really good.
Thank you.
Just saying.
Apple fritter?
Oh my God.
Yourself and it's 3, so-
Don't knock it till you tried it, first of all.
Stay with the.
Yeah.
Stay with the Fruity Pebble, because when you see Fruity Pebble, you're like, oh, it's no good. And then there's like a little crunchy goodness there.
I was surprised.
All right. So we're back to little Blair Witch Project right there, sorry. We're back to this. Who's college algebra? All right, good job. What do you represent? Y'all's class get 25,000 points. All right.
What about my $2,000?
What,
Pesos,
$2,000?
37,000 pesos.
Oh yeah, that El Chapo was going to send that.
I thought it was the college. No.
The college, I can't get the college by camcorder. You think they're going to send out 2,000 pesos?
$2,000.
$2,000.
20,000 pesos.
20,000 pesos. All right. Here we go. When is f of x equal to 0? When is f of x equal to 0?
Curly bracket 0, union, curly bracket 6.
How about we just do curly bracket 0, 6, curly bracket?
Okay.
Same thing.
Okay.
Same thing. All right. Hey, Brantley, are we up to any views?
We are currently at 2 viewers.
So you?
And you.
When is f of x less than 0?
0, 6, parentheses.
0, 6, two in parentheses. Very good. 0,
I
6.
love how hard we're trying to push this and just no one's watching. And you know why? It's probably because anybody who like cares to actually get extra help is willing to just come into class instead of pulling it up. Like that's what I feel like. I feel like if you're willing to go the extra mile to get the extra benefit.
But what if you live like in Poinciana?
Yeah,
Why
but
do you
your
come
computer
here?
lives in Poinciana.
Well, I actually have several students who live in Poinciana.
Really?
Yeah.
What?
Lincoln's living like, you know, Jacksonville right now.
Why don't you just? Because I was talking. Oh, well, that too.
And he doesn't get his own to watch it online. You gotta buy his own.
We need,
Alright.
we need to send people like virtual donuts.
F of x is greater than or equal to 0. What do you get?
And then we do it.
Negative infinity to 0 bracket, union, bracket 6 to infinity.
And I do believe, Brantley, that some people watch it later. Actually, I know for sure that people watch it later. So it's actually worthwhile. But,
Is that gonna be on the YouTube channel?
Yes.
yes, ma'am.
I subscribed.
Appreciate you. We have another donut. All right.
Oh shoot, I'm subscribing right now.
You know what? Because I wasn't sure you were going to come. And the fact that you were an hour and 15 minutes late kind of confirmed that thought process. All right.
9 o'clock.
Potato, potato. All right. Write the equation. This one's tough.
Yeah.
This one's tough.
I didn't know what to do for that one.
You think you got it?
I have an equation.
Go ahead. Let me hear it.
Y equals parentheses x minus 2 parentheses squared minus 1.
X minus 2 squared.
Minus 1.
Well, that's not in this form.
It's in the form I see. I said I had an equation.
All right, let's take a look. This one's tough. So what makes this one so tough? By the way, this is on the test.
Really?
Yes, 100%.
I don't even know how to start.
Yeah, I never seen that type of equation.
All right, so a couple thought processes. Number one is in section 3.2, we haven't really gotten that far into 3.2 yet, so maybe you wouldn't have seen it. Number two, if you don't ever do the homework, you'll never have seen it. But you showed up on a Friday, so now you've seen it. Okay? That's my point. If you don't want to do the homework, at least come in on the days I give help, because it almost offsets it. All right?
Sometimes. I do reviews.
Y equals A, x minus 2 squared minus 1. Do we agree?
Yes.
This would have a vertex of 2, negative 1.
Oh, okay.
And there'd be some coefficient out front, which I don't know what it is. Do we agree?
Yeah.
Now, here's what I do know. What I do know is that 5, 7 is a solution. So 7 equals A times 5 minus 2 squared minus 1. Do we agree? So 8 is equal to A times 3 squared. So A is equal to 8/9. Okay. Now, how do you get the final answer? It's 8/9 times x minus 2 squared minus 1. Do we agree? Which is 8/9 times x squared minus 4x plus 4 minus 1. Do we agree? Which is 8/9 x squared minus 32x over 9 plus 32 over 9 minus 1. Do we agree? If I distribute the 8/9? which is 8/9 x squared minus 32x over 9 plus 23 over 9 if I find a common denominator and simplify.
This is hard.
Wait, so it was 32 ninths and then it was 20.
32/9 minus 1.
Oh, okay.
32/9 minus 1 is 23/9.
Are you gonna like do more of these? Or like touch?
No, no.
What?
You want to do another one right now?
I mean, sure. But hold on, I'm taking a picture. But like before the test.
Maybe we should do a lot of these before the test.
Yeah, this is pretty.
Well, there's still other stuff you haven't seen yet. This is like Christmas. Don't get bogged down playing with one gift. You have a bunch of them.
Yeah.
I mean, we still got discriminant to talk about. We got solving equations to go over. I mean, there's a lot of fun to be had in this chapter. It's a little playground right here. Camille, you okay, baby?
Wait, so that's the final answer?
That's your final answer.
Okay.
We good? Let's have some fun. Hey, we'll try another one just like that. Now that you've seen how to do it. Write the equation where the vertex is -4, 3, passing through -6, 12. Also, write the equation where the x-intercepts are x equals 5 and x equals -3/2. Let's try those two. All right. All right, here we go. Whoa. What did you get for that?
64x to the 16th, y to the 21st.
64x to the 16th, y to the 21st?
Yeah, and z to the 5th.
Is that on bottom or top?
It's on the, no, it's on top. No.
All right. Let's take a look. I mean, it sounds really good. Ryan, did you check that?
I don't remember.
Yeah, he did. I had him, I put out here blurring answers, but I don't know if they're right.
That's faith, Brian, right? 64 x to the -4, y to the 6, z to the -10 is going to be on the bottom, times x to the 20th, y to the 15th, x to the -10, z to the 5th. We agree? Now, negative exponents have to move from top to bottom or bottom to top. That's how this system works. Okay? So, x to the -4 will go to the bottom, z to the -10 will go to the top. X to the -10 will go to the top, yes? So what we have here is 64, z to the 10th is on top, y to the 6th, x to the 20th, x to the 10th, y to the 15th, over x to the 4th and z to the 5th. So we're moving the z to the top, that comes here. The x to the -4 moved to the bottom, that's there. The x to the -10 moved to the top, that's this piece right here. And then everything else stayed where it was. Now, once we do that, if they're side by side, we add them together. So we got 64, z to the 10th, x to the 20th, x to the 10th is x to the 30th, y to the 6th, y to the 15th is y to the 21st, over x to the 4th and z to the 5th. Okay? Now, if they're on top and bottom, we subtract, but the answer, the exponent stays where the biggest number is. So x to the 4th goes into x to the 30th 26 times. Z to the 5th, z to the 10th becomes z to the 5th. Giving you a final answer of 64, x to the 26, y to the 21st, and z to the 5th.
Yeah, I didn't move the negatives until after.
Yeah, I generally move them, once I get to a point where they're all done, then I move them and combine them.
So do you move them first or after you put them in?
Once I bring the exponents in, then I'll move, my next step is to do the negative exponents after that.
Oh, okay.
But I always move I bring the exponents in first, and then move any negative exponents I have.
Does it make it, well, I guess it kind of did make a difference.
That's easy to catch sign errors first.
It doesn't technically matter, but
You got x to the 26, and mine was 16. Plus Oh, I think I had that at first.
yeah, so it functionally doesn't make a lot of difference, but it does matter some if you don't do it right, I guess.
Okay, I see.
All right, factoring. What's common between 18 and 24? What number goes into both? 6. You get 3x plus 4y. Okay. What's common to the next two? 2xy to the 4th. Very good. When you're given a choice, pick out the smaller of the exponents. Take out anything common to both numbers. What are you left with?
3x plus 4y to the
3x plus 4 y to the 3rd. All right. I'm going to leave you with that. I did you were done anyway, but I'm leaving you with that. All right. All right. If we can repeat letters, Terry Ann. Oh, shoot. Maybe I should move this. If we can repeat letters. Love you, baby. Take care. If we can repeat letters, that is 26 to the 6. You agree? Now, if you cannot repeat letters, it's 26 times 25 times 24 times 23 times 22 times 21. Okay? This is actually called 26 P6. Okay, it's called a permutation. And the reason why it's a permutation is the order matters. See, when you're typing in an access code, you don't get to reverse the letters around and call it good. Right? And so in that case, the order does matter, and so it's a permutation. If the order didn't matter, it'd be a combination. Okay? All right, we're going to play paper, rock, scissors. What's the probability you lose 4 times in a row? Probability you lose 1 time is 1/3. We're going to raise that to the 4th. It's 1 over 81. So it's 8. All right. We're going to leave that with you. Yeah. That was the whole you coming in late part. I gave you something.
It's on a video though, right?
Yeah, it's on there.
Cool.
All right.
I did for a second too. I woke up and was just like,
No, 9 o'clock. is what time you get here if you don't want to see much.
Oh,
All right. If you want to get here when it's over, and quite possibly not get a donut, except if you put a request for plain, you'll always have that.
also,
then you're
Mr.
good.
Driver, Tori, that's also in this class, the other white girls in the intermediate.
Yeah, the one who told me to bring all the extra donuts and didn't show up. Yes, that girl.
Yeah, you know what, that might be a big me fault, because when she did text me what time to show up, I did tell her about like 9, so, but I did text her later on, like 7:51 a.m. that
So it does start at 8.
Wait,
gotta tell
you texted somebody at 7:51 and told them to start at 8? Good looking out, Lincoln.
She texted me like 12:27 a.m. and I was just like, it's 11, it's like 7, or no, it says 9. I was like, I woke up, I realized.
All right.
She was one, I told her 8.
That's the first part. Do we agree? That's the first part. Now, it's got to pass through negative 6, 12. So 12 equals A. Negative 6 plus 4 squared plus 3. So 9 equals A times 4. So A is equal to 9 over 4. Do we agree? So we got y equals 9 over 4, x plus 4 squared plus 3. This is 9 over 4, x squared plus 8x plus 16 plus 3. Love you, Dino.
Much love.
We distribute 9/4 x squared plus 72x over 4. Plus, I'm sorry, I can't do that. 9 over 4 times 8. This is 18. Do we agree? 9 over 4 times 16. You good?
Yeah.
Equals 36. Plus 3. So 9 over 4. X squared plus 18x plus 39.
Would you write that like y equals in that?
Yeah, y equals. Now, what about this one? Go ahead.
I don't.
You got it, go.
I don't have an answer for
Brad.
Spent the whole time on the first question, because I had the
Figure it
negative 6
out.
and 12 flipped
that. I
around.
could figure it out.
X minus 5 is the first piece. Do we agree?
Yeah.
Yes.
This piece would have to be 2x plus 3. Do we agree?
Yeah.
Because if we're solving backwards, right? So this has got to be y equals, yeah? Produces the final equation of 2x squared minus 10 plus 3 is minus 7x minus 15. And there's actually a number of answers that you can take for that, because any linear combination, you can put any number out front you want to, right? If there's a 7 here, it has no effect on the problem. If there's a 6 there, it has no effect on it. If there's a 45, it has no effect on the problem, in terms of these two answers being the same. So there's actually any number of combinations of answers that will work for that, all of which are linear combinations of that. We good?
Yeah.
All right. We're going to stop you there. I need to get into downtown and go see somebody. All right. So we're going to stop there for today. I appreciate you guys coming in. If there's any donuts left, please make sure you take them. All right. With that, we're out of time. We'll try to be next time. Thanks for coming. Did you have a question? If you had a question, I'll answer it.
I was making sure, like,
So you good, Brentley? Appreciate you, sir.
Yes, sir.